Hello guys, today we are going to discuss about implement and demonstrate Q learning algorithm. Myself Rishi and I'm studying from Sri Venkateswara College of Engineering. Content. Today we are going to discuss about introduction, Q learning overview, Q table, basic Q learning algorithm, off policy learning, Q learning example, convergence and optimality, applications of Q learning. Introduction. Reinforcement learning is an interdisciplinary area of machine learning and optimal control concerned with how an intelligent agent ought to be actions in a dynamic environment in order to maximize the cumulative reward. Basic components: agent, environment, actions, and rewards. A reinforcement learning model has four essential components: a policy, a reward, a value function, and an environment model. Q-learning overview. Explanation of Q-learning as an valued-based reinforcement learning algorithm. Q-learning is a free model of policy reinforcement learning that will find the best course of action given the current state of an agent. Use of Q values to iteratively improve the behavior of the agent. Q learning uses Q values to represent the expected cumulative reward of taking a particular action in a particular state. Q table. Building a table of Q of S, comma A values. The Q table is a lookup table where we calculate the maximum expected future rewards for action at each state. Initialization and update of Q values based on the agent's experience. To learn each value of Q table, we use the Q learning algorithm, which involves an iterative process of updating the values based on the agent's experience. Basic Q-learning algorithm. Description of the key steps is in the Q-learning algorithm. Q-learning is a model-free reinforcement learning algorithm to learn the value of an action in a particular state. It does not require a model of the environment and can handle the problems with stochastic transitions and rewards without requiring adaptations. Exploration and exploitation phases. The Q-learning algorithm involves a balance between exploration, trying new actions, and exploitation, choosing actions based on current knowledge to find the optimal policy. Of policy learning. Explanation of Q-learning as an off-policy algorithm. Q-learning takes an off-policy approach to learning, reinforcement learning, aiming to determine the optimal action based on its current state. The ability to learn Q value regardless of the policy being followed. Q learning allows the agent to learn Q values independently of the policy being followed, which contributes to robustness and flexibility. Q learning example. A step-by-step illustration of the Q learning process in a simple environment. A Q learning example can demonstrate how an agent learns to make decisions based on the Q value associated with different actions in various states. Initialization, action selection, and Q value updates. The Q learning process involves initializing the Q table, selecting actions, and updating Q values based on the reward received. Convergence and optimality. Discussion on the convergence of Q learning. Q learning aims to converge to an optimal policy by iteratively updating Q values based on the agent's experience and the rewards received. The goal of maximizing the Q value to find the optimal action selection policy. The ultimate objective of Q-learning is to maximize the Q value for each state pair to determine the optimal action selection policy. Applications of Q-learning. Real-world applications of Q-learning such as game playing and robotic control. Q-learning has been successfully applied to various real-world problems, including game playing, robotic control, and optimization tasks. success stories and challenges in applying Q learning to complex problems. While while Q learning has shown success in many domains, also presents challenges such as scalability, spaces, and environment. Thank you.